Okay, make sure your name's at the top. Yes, I'm using a larger copy. Just write small on yours, smaller. The first one, it says fill in the blanks, and it also makes a note that you have to study all your geometry vocabulary. So anytime you have an exam review and you're studying specific words on the exam review, think about what else they could ask. So the first one says the intersection of two non-collinear rays at a common endpoint is known as what? So two non-collinear rays at a common endpoint is an angle. The next one says a blank is a location. It has neither shape nor size. That is a point. If they're reviewing point here, they could maybe ask you about a line on the test or something similar to that. That makes sense. Right, Jamarius? Then the next one says blank lines are two distinct coplanar lines that do not intersect. That would be parallel lines. And again, if the exam review has parallel lines, perpendicular might be something that they have on the test. So just kind of prepare yourself to answer questions about perpendicular lines. A flat surface made up of points that extends infinitely in all directions would be a plane. Okay, the next one says determine which of the following statements are true if triangle CAT is congruent to triangle LUV. This is not multiple choice. Some people are thrown off because they didn't show a picture of these two triangles. If you wanted a picture, you could draw a picture. But what they're getting at is that with the congruent statements, they're in a specific order, and the corresponding angles are in that order. So for example, angle C is the first letter here. That would correspond with angle L, and C and L would have the same measure. The middle angle, angle A, would correspond with U, and those two would have the same measure. Also, that works with segments as well. So segment CA, the first two letters, would correspond and be congruent to LU over here. So as long as they're in the same position, they're congruent. So now we're going to look at each of these and see if they're true or false. Is angle C congruent to angle L? Yes, that is true. Then for B, is CA congruent to VU? No, CA is the first two letters and VU is the last two, so that would be false. The next one is angle TCA equal to VLU. That is true. I know it's kind of harder to see, but it's last, first, middle letter, last, first, middle letter, so that is true. For the next one, TA congruent to VU. TA are the last two letters, VU is the last two letters, so therefore that is true. And last but not least, angle TAC equal to VUL. That is true. Okay, number 2, it says explain how to prove the two triangles congruent using SAS, side angle side. It says given D is the midpoint of BC. So that means BD would be congruent to DC. So we're going to start there. BD would be congruent to DC because of definition of midpoint. So we have one set of sides congruent. They want us to use side angle side, so we need to prove that these two angles are congruent. The way they prove it is kind of wordy. I'm going to try to shorten it as much as I can. They're saying since this is a 90-degree angle and it forms a linear pair here with the other angle, those two are supplementary, so this must be 90 degrees as well. And if they're both 90 degrees, then they're both equal. Do you want me to repeat that again? Because I'm not going to write that all out. Okay, so they're saying since this is a 90-degree angle and these two angles form a linear pair, they must be supplementary. They must add to 180. Therefore, this has to equal 90 degrees, and angles that are both 90 degrees are equal. So I'm going to write down angle BDA is congruent to angle CDA. The reason? I don't know. It started out with something supplementary, right? And then it went to that they're equal. So we'll just leave it as that, at that. Then we also need to prove that this is equal to itself. So segment AD is congruent to segment AD, and that is reflexive property. And so now you have side, angle, side, side, angle, side. You can say that triangle, make sure I get the BDA is congruent to triangle CDA because of side, angle, side. Okay, next one says which statement will be needed to prove that triangle JKL is congruent to MNL using angle side angle. Given here, they say angle KJL is congruent to NML. So it's telling you this is congruent. Okay, we would also need to know that this angle is congruent to this one. So angle JLK is congruent to angle MLN by vertical angle theorem. Tomorrow with the escape room, we're going to be working on congruent triangles. We're going to be working on side, angle, side, 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 and all of that. So there will be some more practice with it. Number 4, which postulate or theorem can be used to prove the following triangles congruent? Write a congruent statement for each pair. For A, I know that this is equal to itself, so we have two sides that are congruent. What else do we have? It shows that these lines are parallel. That means that this is a transversal. With a transversal, alternate interior angles are congruent, so I know these angles are congruent. I also see that these lines are parallel as well. That means I have a parallelogram. Parallelogram, the opposite angles are congruent. So this entire angle is the same as this one. That means that this angle must be the same as this angle because those two angles add to the same thing. Then we have angle, side, angle, and angle, side, angle. And that's your congruent statement. And as you saw with the homework, just type in ASA. It doesn't have to be capitalized. You would just type in those letters to get it correct. For B, this is equal to itself, and then you have side, side, side congruence. For C, vertical angles are congruent, and then you have side angle, side, side angle, side. Number 4, if the triangles below A equals D, C equals F, and B equals E, what can we conclude? Well, angle, angle, angle is not a congruent statement. They're not congruent. Well, they could be, but we can't prove it. They're not congruent. When you have angle, angle, angle that's the same, they're similar, they're proportional. So the triangles are similar, and we'll look at proportionality of triangles next semester, but for right now, they're proportional. Draw an example of a triangle that would prove that the following statements are false. Okay, so this talks about right triangles. It says all right triangles are equilateral. That is definitely false. Why? Well, right triangle, it can't be equilateral. That hypotenuse is always going to be longer. So just all the sides wouldn't be the same. The next one says all equilateral triangles are congruent. That is, of course, false. Equilateral means that all the sides are the same length. So you might have an equilateral triangle with the side lengths of 3. You could have an equilateral triangle with the side lengths of 5, or any number. So it's like draw an example of a triangle that would prove the following statement false. So that's what we did here. And on to the next side, the next page. I'm going to flip the page. See, all triangles fit the pattern a squared plus b squared equals c squared. That is false. Only right triangles follow the pattern of a squared plus b squared equals c squared. Only right triangles. So for example, if you had an equilateral triangle, 3 squared plus 3 squared would not equal 3 squared. I know you're trying to squeeze it on your page wherever you can, off to the side or whatnot. D, all isosceles triangles fit the pattern a squared plus b squared equals c squared. Some would, but not all of them. Not all. For example, here's an isosceles. Let's say it's 9, 9, and the base is 14. 9 squared plus 9 squared would not equal 14 squared. A right triangle could be isosceles, but they're saying all of them? No, they would not. And the last one, all regular triangles fit the pattern a squared plus b squared equals c squared. Regular triangles or regular polygons, that word means that all the side lengths are the same measure and all the angles are the same measure. If it says a regular polygon, they should have just called it like perfect polygon, because that's what they're talking about. So anytime you see that word regular, it seems like it's unimportant, but it actually means a lot. It means that shape, all the lengths of the sides are the same and all the angles are the same. So all regular triangles fit that pattern, and no. Again, 2 squared plus 2 squared would not equal 2 squared. Okay, so now we're going to look at congruent statements of triangles. To prove triangles congruent, you can either use side, 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 angle, side, angle, angle, side, or the fourth one is angle, side, angle. The two that do not work are ASS, that doesn't work, and angle, 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 doesn't work. Okay, so when we're looking for these, we're looking for one of these four things in both triangles where it matches. For number one, I know that this is the same as itself, and then I have angle, side, side, and angle, side, side. Angle, side, side is not a congruent statement, so therefore, nope, we can't prove that these are congruent. They might be, we just can't prove it. 2, this is the same as itself, and then we have angle, side, angle, angle, side, angle. 3, we have this is the same as itself, and then we have side, side, side. For number 4, vertical angles are congruent, and then you have angle, side, angle. For number 5, it only shows an angle and a side congruent, nothing else. In this case, we can't prove that they're congruent. We don't have enough information. Number 6, vertical angles, of course, are congruent. So then you have angle, side, angle. And 7 is a trick. 7, for this one, you have side, angle, side. And then you have angle, side, side. So you have side, angle, side, and then angle, side, side. They don't match, so therefore, no. Nope. Okay, and moving on. Okay, so here it has a proof, and it wants us to fill in the reasons. This picture here, the E is in the wrong space. E should be down here. Okay, so it says CD is congruent to DC. That is the reflexive property. So this is equal to itself. Then it says that the triangles are congruent, and that would be because of side, side, side congruence. Then once you know that the triangles are congruent, then the corresponding parts are congruent. Here it's saying angle B is equal to angle E, and the reason why they can say that is corresponding parts of congruent triangles are congruent. And number 2, determine whether each statement below is true or false. Parallel lines meet at exactly one point. That is false. Again, think about how they might ask that on the test. Well, intersecting lines meet at exactly one point. Maybe they'll switch it around on the actual exam. Next one says an angle bisector creates two congruent angles. That is true. Angle bisector does create two congruent angles. Corresponding parts of congruent triangles are congruent. That is true. Supplemental angles have a sum of 90 degrees. That is false. Supplemental angles have a sum of 180 degrees. And E, the altitude from the base of an isosceles triangle creates two 90-degree angles. So I have an isosceles triangle here. Let's say this is 5 and 5. We draw the altitude. It does create two 90-degree angles. That is true. Three, write an equation that could be used to solve for x and y